Good morning, my YouTube viewers. It's Crystal here. I just wanted to give you another code review, and basically the code review that we're going to be going over today is going to be the KNN Classifier. And so what we're going to do is we're going to compare the KNN Classifier to sklearn's KNN Classifier. And so I was doing a lot of research, and we did lots of research on the IRIS dataset. So almost every KNN classifier that I came across used the IRIS dataset as an example. And I believe that the reason for that was because it did such a good prediction. And I wanted to use a dataset that wasn't the IRIS dataset because pretty much everybody's using the IRIS dataset. So I went on to Seaborn, and I got a dataset from Seaborn, and I'm using that. So we're going to go ahead and go over the code review. So the first thing we're going to do is we're going to make the IRIS dataset, the KNN classifier from scratch, and we're going to create the functions that need to be created in order to do that. So we're going to, we've created this program in Google Colab because Google Colab is the platform that I like to use. It's a really good platform. It does a lot of things, but it doesn't do, it doesn't do everything. It is early in the morning. It's the middle of the night as I'm making this video. And then so we do the program in Google Colab, and I got the algorithm from this website here, but they use the IRIS dataset. Almost every website that I went through to find KNN was using IRIS dataset, and I thought, well, that's not very good to use the IRIS dataset, and it seems to me that like everybody was just copying everybody else's work. And so I thought I'd try one that wasn't the IRIS dataset. So this dataset that we're using is the exercise dataset, and it doesn't have as good an accuracy, but at least it's a little bit original. So after we created the program, what we're going to do is we're going to import our libraries. And so we import NumPy, which is a numerical library, and SciPy, which is a scientific library. And then we create the function called Euclidean. And when we create the function called Euclidean, it's the Euclidean that is going to be determining who the neighbors are. And there's other functions that you can use as well, such as the Manhattan, but they've used the Euclidean in this example. And we can get the formula for the Manhattan and put the Manhattan formula in there and see if the Manhattan gives a better accuracy. And then so the formula for Euclidean equals dist equals np dot square root brackets np dot sum brackets p1 minus p2 brackets to the power of 2 brackets. And then we have the function to calculate KNN, that's your nearest neighbor. So we go through the function to calculate the KNN, and you can see right in here when they iterate through all of the different rows in the data set, you can see that they've calculated the Euclidean distance. So this is your formula for your calculating your KNN right here. And then what the KNN does is it does all this stuff to it. And then at the end, what it does is it returns the off labels. So your off label is going to be your Y-pred. And the Euclidean and the function for KNN, it accepts your X train, comma, Y, comma, X input comma, K as your inputs. So now we're going to go through the actual formula that we're going to use. And we're going to import some more libraries. So we're going to import sklearn.metrics, import accuracy score, import seaborn as SNS, from sklearn.utils, import shuffle, from NumPy random, import randint. And so we're going to load the data. In this instance, we're using Seaborn's exercise data set, and we're going to be not using the first two columns. So your iLoad code right here is where it's not using the first two columns. So these are the columns that we're going to be using in this program. We're going to be using the diet, the pulse, the time, and the kind. So what we do is we do a disk plot on the kind, and you can see that all of the three categories have the same amount as being 30. So you have 30 as rest, 30 as walking, and 30 as running. And so that was similar to the iris data set, because in the iris data set, I believe you have 150 and rows of data, and 50 of those are going to be one type of iris each. So we're going to check out the info for the exercise, and you can see that the diet is a category, the pulse is integer, the time and the kind are categories as well. So we're going to find the unique values for each column that is of type category. So we're going to get the unique values, and we're also going to get the number of unique values for each column. So in diet, you have the number of unique values is 2. In time, the number of unique values is 3. In categories, the number of unique values is 3. So what we're going to do is, because we can't predict upon strings, so what we're going to do is we're going to replace all the strings in the data frame with numbers. So low fat is going to be replaced with 1, and no fat is going to be replaced with 0. And then 1 minute is going to be 1, 15 minutes is going to be 15, 30 minutes is going to be 30, and rest is going to be 0, walking is going to be 1, running is going to be 2. And so we're going to replace all of that. And so now we have a data set where the categorical values and the label have been encoded. So we're going to check for any null values. We check for any null values. There are no null values in that data set. And now we're going to define our x and our y value. So your x value is going to be exercise, diet, pulse, and item. And your y value is going to be exercise.kind. So we're going to shuffle the data set, shuffle the data frame. And then we're going to create the training set and the data set. So the training set is going to be 90% of the data frame, and the test set is going to be 10% of the data frame. And now we're going to apply the KNN function, ypred equals predict, xtrain.values, ytrain.values, xtest.values, and 7. And we're going to check for our accuracy, and we get a 67% accuracy. And now we're going to compare this with sklearn, and when we compare it with sklearn, we fit it in with the number of neighbors as being 7, and we have 67% accuracy as well. And so I went through and I checked it, and I did lots of things, and I could not get the accuracy higher than 67%. So this is the difference between the exercise data set and the iris data set. So on the iris data set, it gets a really high accuracy. It gets like a 96 or a 98% accuracy. But on this particular data set, it doesn't have as high an accuracy. But I just wanted to do something a little bit different. I didn't want to use the iris data set because that's what everybody else is using. And that's it for this code review. We've compared the made from scratch version of KNN with sklearn's version, and you can see here that there's no difference. They both perform the same. So that's interesting. So thank you very much for watching this video, and I look forward to making more videos for you in the future. Thank you so much for supporting my channel. And if you like my video, please like, subscribe, and share. And goodbye.